Okay, so what do you think? Is it simpler or more difficult?
Simpler.
Okay, let's start with A. That's always the case, right? Okay. Now, if the import if the import is one, or if the import is zero, where are we gonna go? We're gonna go to a state, right? And the import is one. Let's say 0, 1. Okay. If import is 1,
Accept state.
we're actually in the acceptor state, right? Okay. Now, set of all string over 0 and 1 that start with 1. Okay. So once we actually go to the accepting state, if you have another any import 0, it stays in this accepting state, right? Because once you got a 1, once you got the first character 1, the digital 1, and then it doesn't matter what is the next one, because it's just start with 0, 1. This is start with 1. It really doesn't matter what is the follow-up digital, right? So it's always acceptor state. 0 or 1, they always stays in the acceptor state. Now what about 0?
Reject.
Okay, we'll go to another state, and we have another name for that state, because the set of all string over sigma that start with 1, but then we have a string that start with 0. Now, no matter how many strings we're going to actually add after 0, this is always going to be rejected, right? Because there's no way you can make it a string that start with 1, because it's already started with 0. And we have another name for that kind of state. Let's see, what's the name of this? Um, we call it dead state, okay, or trap state, a rejecting state that is essentially a dead end. Once the machine enters a dead state, there's no way for it to reach an accepting state. So we're trapped. Okay. So we're gonna end up with a state C. That's called a dead state. Okay. So no matter what what is the follow-up value, it's always dead state. Okay. So that's pretty simple, right? Because when we have a string, um, so let's actually check that one. So for this, let's see. Let's fill up this. So we have a start from A. If it's if the import is 0, we're going to C. If the import is 1, we're going to B. Okay. Okay, B is accepting state, right? And in a B, it doesn't matter whether it's 0 or not. So we're also we stays in B, right? If it's in C, it doesn't matter whether the import is 0 or 1. We stays in C. Okay, C is a dead state. Okay, that's the transition function. Okay, so we have three states: A, B, and C. And this A, final state is B. Start state is A, and also the dead state is C. Okay, let's check which of the following import string does the machine accept. Again, as I say, I know this is going to be rejected and this is going to be accepted, but we're talking about a machine, right? So let's say uh, initial state is A. So the first import is 0, so we go to C. A 0, we go to C. And then the follow-up import is 1, we stays in C. Follow-up state is 0, we stays in C. So it doesn't matter whether it's 1 or 0. So, and C is data state. It's not an accepting state. So we reject it. And here, start from A, and 1, we go to B. And then it doesn't matter what is the next import which stays in B. Next import which stays in B. So it's accepted. Okay. Same thing with this, right? Once A actually goes to B, and then it's always stays in B. So the final state is always B. So pretty simple uh, finite automata. Now let's talk about this. Build a DFA for a language. For language L1, which is a set of all strings over 0, 1 of length 3. Okay. Length 3. Is this a simple one? Let's see A. If the value is 0, we don't know whether. So it's not definitely not gonna be an accepting state, but it's also not a data state, right? So it's an intermediate state. And if it's another, again, it's 0, we go to C. Again, it's 0. 0, 0, 0. What is this? D.
Accept state.
Accept state, because it didn't say what's the pattern of this import. It just say if the length is reaches 3, it's accepted, right? Now, what is the next one? If we continue to get a 0,
Dead end. Dead state. Sorry.
that state E. And if it continue goes to 0, it stays in E, right? Never gonna be out. Okay. Now, what about a 1? I think whether it's 0 or 1, we always go to B. And whether 0 or 1, we always go to C. Whether 0 or 1, we always go to whether 0 or 1, we always go to E, right? So this is a very strange kind of finite automata. So so it the value, the import value is not important. The length is important. So for every value 0, 0, 0, 0, 1, 0, 1, 0, or 1, 0, 1, it's always intermediate state. And once you reach the three actual digitals, it's always actually reaches the accepting state. And after the accepting state, if you have a more actually digitals after the 3 digitals, then it's no longer accepted. Any actually string with less than 3 digitals or more than 3 digitals are all rejected. Only actually 3 will be accepted. Okay. That's a kind of strange one. Let's take a look at this. Okay. Now that state machine is actually the transaction function is kind of seem interesting. So A 0, we go to B. A1, we also go to B. Okay. Now if in the B state 0, we go to C. 1, we go to C, right? And we go to D, we go to D, and D is accepted state. And then if the current state is D, which is accepting state, but we add one more import, we go to E, right? add 1, we go to E. And also, if its current state is E, it doesn't matter what's the value, we stays in E, right? So that's um, the transition function. Now, one thing you need to remember for the deterministic finite automata. So for every state, for if you are in a particular state, then you have to think about all the possible import value. And for different value, you're probably going to go to a different state. But you need to think about all the possible import and determines what's the next state if the import value is this. If the imported value is the other one, what's the next state? You have to make sure the finite automata are going to be complete. Okay. So in another word, if I building a finite automata, I'm gonna say, okay, if it's A, if it's 0, I'm going to B. If it's zero, I'm going to C. If it's 1, I'm going to D. Now this is not a complete one. Okay. Now, people can ask if its current state is A, and the import is 1. Where is this gonna go? So you have to define for the state A, you have to define what's the next state if the value is 1. Okay, so for 1, you have to define it. It could be here or could be here. It doesn't matter, but you have to define the value. And also for B, yeah, B is completed. If it's 0, go to C. If it's 1, go to D. But for C, you haven't defined actually. So for the transition function, you have to define for every value. For the C, you can actually say if it's 0, go to D. If it's 1, go back to B. That's okay. Now for D, if it's 0, stays in itself. And if it's 1, you can say, oh, I'm going back to A. Now that's a complete state machine, okay, or finite automata. Because for every state, then I define the next state for each import value. Okay. I think we still have time, so we can do more examples. Okay. Okay, here's the finite automata for language L set of all string over A, B, C, D, E, F, G, all the way to Z. It's an alphabet. Okay, it's a real alphabet. So actually for language L that start the word for. Okay. That's interesting. Now you have, for this alphabet, we have 26 symbols, right? For A to Z, it's a 26, right? Is that correct? So what do you think? Let's start with the A. So all the string over alphabet A, B to Z, A, B, C, all the way to Z, that starts the words for F. So let's think about this. If it's F, that's good. So we are going to a next state, even though it's not a final state, but at least this is leading to. It's actually this going to lead to an accepting state, right? Now, if it's O, we're going to C, and if it's R, we're going to D, which is
Accept.
accept, right? And then it doesn't matter whether it's A, B, C, or X, any values, X, Y, Z, it stays in D, right? Because you start with a 4. Okay. Now, if I start with A,
Dead state.
okay, it's a dead state. B is also a dead state. So all the alphabet A to Z, X, not F. Okay. Okay. Now, if I'm in D, I'm actually, if the first one's F, and then if it's 0, oh, not 0. If it's O, go to C. If it's not O, also go to a dead state, right? And this one is not R, go to dead state. And once you're in E, really, it doesn't matter, you know, from A to Z. It's all stays in E. Okay. Okay. That's the so. Any questions? It look good. So what do you think? Is there any questions for this? Okay. So that's the next one, um, which is pretty good. So the next one is the example is example number 5. Let us build a DFA for language L set of all string over 0, 1 that contains the string 0011. Or the next one, let us build a DFA that for language L set of all string over 0, 1 that don't contain with string 0011. Okay. What do you think? Okay. I'm gonna leave this for now, but that's pretty much all the materials I want to cover for today. Uh, so let's actually work on the first one. If the second one requires some thinking, you know, the first one should be relatively simple. So let's actually complete the simple one, and I leave the second one for, you know, you can think about this after the class, and then we're going to talk about, you know, next class. Example 5. A. So think about the 0. Think about another 0, right? And think about a 1. And think about a 1. So always, you know, and then it's them, right? And then 0 or 1, it stays in here because you already have this. Now, what about A? If what about in 1? I'm sorry, not A. So 1 is not really a good number, right? We hope to see 0, and then we can continue. But if we see 1, that means it's not a good sign. So what are you going to do? I'm going to stay in 1A. Is that good? If I continue to see 1, then I'm staying here. Now, so for A, if it's 0, go to B. If it's 1, stays in A until next one 0 and go to B. Now, once I'm in B, if I got a 1, so it looks like the first one is 0 and the second one's 1. That's not good, right? So where should I go?
Back to A.
It sounds like I messed up everything. Everything I've done so far, it's all messed up. I have to restart from A again, right? Back to A. So now over here, so if I'm C, so that means I already have 0 and a 0. Okay. Once I got a C, I already have a 0 and a 0. So I'm in C, the state C. So I already, it doesn't matter. Probably I just repeat it many times 0, 1, 1, 1, 0, but 1. But here we are. I got a C here, right? So now if I got a 0 here, so that means I got a 0. What should I do? Stays in C, right?
Yeah.
Is that right?
Yes.
Stays in C. Because it doesn't matter how many times I'm actually stays in C. That means if I continue to get a 0, I got more zeros. But once I got a 1, I can go to D, right?
Yes.
Okay. Now here's a tough one. If I got a 0 here, so looks like I got the 0, 0, 1. I'm almost there, but I suddenly got 0.
Back to C.
Back.
Back to C?
Hmm?
No, back to C. If I got a 1, that's not good. You're gonna go to D, but so it should back to B, right? Because I already have a 1 0 here, and I just for B, I just need another one, another 0, so I can go back to C. So if it's 0, yeah, so it should not go back to C. Should back to B, right? Does it make sense?
Yes.
Yes.
Yeah, it's back to B. Okay. So then I can start again. Okay. So I got a 0, and then back to B. Hopefully I got another 0, so I can go back to C. So I can hopefully next two gonna be 1. But if something just mess up again, I need to restart. Okay. Okay. So that's the first one. Now the tough one is example 6. Okay. I think I'm not gonna continue. So I leave that question for you. So hopefully you can answer it, and we can actually work together next, in the next class. So next Wednesday we're gonna work on the non-deterministic finite automata. I can actually work. We're gonna work on some more examples for the DFA, but we're gonna start at the non-deterministic finite automata, um, which seems to be more complicated, but it's not. It's the not NFA is probably not that complicated, but it's different from DFA. Okay. Okay, so we're gonna actually end up a little bit earlier today. So do you have any questions? No questions? Okay. Well, I hope everything gonna be good, and you have a good night.
Thank you, sir. Good night.
Good evening.
Okay. Good night.